Option 3 is correct because we know copper, gold. All are very good. Best one is gold, silver. But silver and gold are very costly, very rarely used. For very for aluminium, used. Here option is correct. You know the formula of resistance dependency on temperature is 1 plus alpha delta T, where this is the resistance at degree Celsius is the resistance at 0 degree Celsius, and this is the change in air, and this alpha is called temperature and now we know alpha is positive for metal air, and this alpha is negative for semi. Means here if we increase the temperature, Indian temperature positive, increasing temperature means alpha positive, so RT will be more than R naught. Is the case of conductor. But if we increase the temperature, for semiconductor it is negative, despite increment in the temperature, resistance is for semiconductor. Resistance is for conductor, metal conductor, resistance at high temperature is H. So here option in the question it decreases. So if we decrease the temperature, resistance decreases for conductors, metal conductors, and for semiconductor, if we decrease the temperature decreases, resistance is at 0 Kelvin. Like semiconductor behaves like perfect. So here option 1 is for conductor alpha is positive. So if we increase the temperature, you know the resistance dependency and is the resistivity at T temperature, is the resistivity at 0 temperature, and 1 plus alpha delta T, just like resistance. So here for conductor alpha is positive is the temperature, then resistance and resistivity both are increased. Option 1 correct. Alpha is negative for semiconductor and insulator. So option 4. Here for copper, for conductor, if we increase the temperature, resistance and resistivity increases, but not linearly. So option C, this question, current 2 ampere passing through the conductor, energy 80 joule in time. You have to find out the distance. We know the formula of heat energy I square RT. So here R can be written as energy divided by I square T. Heat energy is I means 2 square 10, so cancel out 8 by 4. So answer is ohms. Resistance option. This question, power is given watt and voltage to 20. You have to find out the resistance of this bulb. So we know power formula will be P square upon R, means R can be written as P square upon P. P means 220 divided by 60, cancel 1. So R will be 0. So if we divide 6 point something, answer here is approximately 7 ohm. Option here is a capacitor 4 microfarad and voltage here is 400. 400 voltage से charge कर. So energy is stored. Some energy will be stored and potential energy stored in the capacitor is half C square, and whatever energy stored in the capacitor charged through the resistance of 2 kilo. It means whatever energy is stored in the capacitor, it will charge through whatever is the resistance. If the resistance is more and more, time will be taken, and vice versa. So total energy is converted into heat, and loss in energy in resistance, the same energy stored in the capacity. It means heat developed in the resistance is the energy stored in the solvent. The values of C 4 into 10 to the power minus 6, P means square, solvent here was just 32 multiplied by 10 to the power minus 2, 40 cancel हो गया और 0.3. So here option 4 is. We have to convert simply electrical energy unit 1 kilowatt hour into joules. 1 kilowatt means 1000 watt multiplied by 1 hour can be converted into second. So we can write here 36 multiplied by 10 to the power 5 or 3.6 10 to the power 6. So 1 kilowatt hour is equal to 0.6 into 10 to the power this, or can be written as 36% power 5 also, or this. So option C, this question, a bulb of power 100 watt and voltage here is 200 volt. The resistance of this bulb will be P square upon P square means 100 to 200 upon power 100 is 400 ohms. There is no change in the resistance, but suppose if voltage decreased to 160 volt from 100, then power will be different is upon the same resistance are changing. It means now 160 divided by this resistance 400, दोनों जीरो कैंसिल हो गए, 4 जा, so 34 watt. Option D, 5 degree temperature rise, so delta T is 5 Celsius. A conductor passing through current, when current is double, then we have to find out. We know the heat energy is equal to what? Electrical turn, I square RT is the time here, and M as delta T. Delta T is the change in temperature. The change temperature. So M is the mass constant, specific as constant, and resistance also constant. You have to find the rise in temperature for the same time. So everything is constant. Delta T, change in temperature, is directly proportional to I square. So change in temperature in second upon change in temperature first I square. So I2 square divided by I1 square. I2 is double of the initial current. 4 I1 square upon I1 square means cancel, okay, 4 आ गया. Change in temperature in second case is 4 times change in temperature in the first case. 4 into 5 degree. So 20 degree temperature rise. Option here is this question. There are two bulbs. One power 40 watt 200 volts. Getting second 100 watt and volt. It is same. So हमें क्या रिलेशन हो? Distance for valve P square upon P1 means 200 into 100 divided by 40. The second case resistance will be P square upon power 200 divided by 100. So here R2 is simply 400 ohms, and R1 here is 5, and this is 1000 ohms. Here R1 means R for 40 watt bulb, resistance is more than R. Their option is correct.